Today we are talking about factoring the sum and difference of two perfect cubes. Now this is relatively similar to when we discussed factoring difference of two perfect squares, in that we need to recognize certain math facts in practice here so that we can tell that that's what we're looking at. So here the first thing in the notes are the first 10 perfect cubes, which I made you memorize earlier this school year, although a few of you were not in my course at that time. Okay. 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64, so on and so forth. Those numbers, 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000, etc. Those numbers are known as the perfect cubes, okay? And the reason for that is because if we take the cube root of one of those numbers, say we take the cube root of 343, that is an integer. That's why they're called the perfect cubes, because they have an exact cube root. Okay? So there's a pattern that's available to us here, just like there was a pattern with difference of two perfect squares. There's a pattern for both the sum and the difference of two perfect cubes. So we're going to go through these two types of factoring. Well, basically we will show you the pattern as a rule, and then we will apply that rule to several examples for both sum and difference of two perfect squares. Okay? So again, these 10 numbers, 1, 8, 27, 64, 125, 216, 343, 512, basically these numbers, you need to recognize these as being numbers that have a perfect cube root so that you can tell when we're supposed to do this type of factoring. Okay? Those are the perfect cubes. Now, when we have a binomial that is the sum of two perfect cubes, that binomial can always be factored into a binomial and a trinomial as shown in the rule at the top. So we have a cubed plus b cubed will always factor into the a plus b times a squared minus ab plus b squared. Okay? So let's look at that in practice here. Okay? Here is our first example. Okay? 27x to the third plus 512. Well, 27x to the third is 3x cubed. And 512, if we look up above, is 8 cubed. So you can see how that matches our pattern in that A would be 3x and B would be 8. So that will factor into A plus B times A squared minus AB plus B squared. Now that in practice looks easier than it really is to do. Okay, the A is 3x and B is 8. So our first binomial there is 3x plus 8. And then the trinomial, we have a squared, which is 3x squared, which would be 9x squared, 3x times 3x, minus 3x times 8, which would be 24x, plus 8 squared, which would be 64. Okay? So we're just following this pattern here. Okay? We've got A is 3x, B is 8. So we have A plus B, and then we have A squared minus A times B plus B squared. So our answer here would be, well, that factors into 3x plus 8 times 9x squared minus 24x plus 64. That would be the factored form of that sum of two perfect cubes. Okay? On to the next one. So again, we're looking at a pattern here. We have, but we always need to remember that no matter what type of factoring we're doing, whether that be trinomial, binomial, grouping, any type of factoring that we do, you always have to start by checking for the greatest common factor. So when we look at this problem, this next problem, right away we shouldn't really see a pattern yet, except that we should notice that both have a GCF of, well, let's see there, 2x. Okay, we can take a 2x out of both of those terms. So that would be our first step, is to factor out the 2x. Remember that when we factor out 2x, that is like dividing each term by 2x. So that would leave us with 8x cubed plus 27y cubed. Okay? Now if we look, that binomial matches the part up top there, a cubed plus b cubed. That's why I made it green, just like up top. Okay? So we're going to leave this 2x out here, and we're going to factor this trinomial following our rule. Okay? So the 2x is just going to hang out front, and we're not going to do anything with it. It's just going to sit there. For the rest of the problem, it'll be part of the answer. Okay? Our a plus b would be the cube root of 8x cubed, which would be 2x, plus the cube root of 27y cubed, which would be 3y. So that's our a plus b. Okay? Because we've got a term cubed and a term cubed. This becomes a plus b. Okay, because how did the 16x to the fourth become 8x cubed? Excellent question. We pulled out the 2x, and when we took out 2x, that is going to reduce the x exponents in the original problem by 1, so that x to the fourth will become x to the third, and the 16 gets divided by 2 to become an 8. Okay? Really wish you guys could just interrupt me and talk like that. All right. So the other part here, the blue part, that up above, we have to really, this is probably the hard part here, is thinking this out. We have to do a squared, so 2x times 2x, which is 4x squared, minus a times b. A is 2x, b is 3y, so 2x times 3y would be 6xy, plus b squared, which would be 3y times 3y, or 9y squared. Okay, we're following a pattern. So our final answer there, we've got the 2x out front, that's from the GCF. We have 2x plus 3y, which is your a plus b. And we have 4x squared minus 6xy plus 9y squared, which is that trinomial. A squared minus ab plus b squared. So that is fully factored. So just like any other kind of factoring, your first step is always to pull out the GCF if one exists. After that, then you need to follow your pattern for sum of two perfect cubes, which says up there at the top with the highlighted part right here, a cubed plus b cubed factors into a plus b times the quantity a squared minus ab plus b squared. Take a screenshot if you want one. We're going to go on to the next example here. Okay, so same deal. This next problem here, we have a GCF. So we need to start by factoring out the GCF. Both terms of this polynomial are divisible by x cubed. Okay? So we're going to take that x cubed out. And when we do that, the two other terms get divided by x cubed. So we would have x cubed times the quantity x cubed plus 729. Well, we should recognize this as being our sum of two perfect cubes, because 729 is 9 cubed from our list up above. So that says x cubed plus 9 cubed. Okay, so we have to follow our pattern here. Which says that our a cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. So again, we're just going to leave this out front, and we're going to factor this guy. So we still have that x cubed sitting out front. That's from the GCF. And then the binomial x cubed plus 729 factors into x plus 9, which is the a plus b, times x squared minus 9x plus 81, which is your trinomial portion of that. So that is the final answer, x cubed times x plus 9 times x squared minus 9x plus 81. All right, so that is sum of two perfect cubes. Any questions before we continue to difference of two perfect cubes, which is very, very, very similar, just a couple of sign differences. Anybody, any questions? Okay, so moving on to difference of two perfect cubes. Same basic idea. If we have a binomial that is in the form a cubed minus b cubed, that will factor into an a minus b binomial and an a squared plus ab plus b squared trinomial. Okay? Now notice how close that is to the other rule. It's only a couple of sign differences. This sign and this sign have changed. Okay? So, once again, we're just going to dive in here and do a couple of examples. Here we have basically, this is in the form a cubed minus b cubed. So it will factor into a minus b times a squared plus ab plus b squared. So we'll have x minus, and what's the cube root of 343? Well, we can go back up and look at our list. 343 is 7 cubed, so the cube root of 343 is 7. So we have x minus 7 for our a minus b. And then for the trinomial, we have x squared plus 7x plus 49. And that is that entire, that's as hard as that problem gets right there. That's our final answer. So x minus 7, x squared plus 7x plus 49. Would be our final factored form for that binomial. Okay, same deal on the next one here. We're just going to follow our pattern. So again, we've got, I'll change the pen color so you know it goes to the new problem. A cubed minus b cubed. So that factors into a minus b times a squared plus ab plus b squared. So that would be 3k minus z and then a squared would be 3k times 3k, which would be 9k squared, plus 3k times z, which would be 3kz, plus z squared. So that would be our final answer, 3k minus z times 9k squared plus 3kz plus z squared. So all we're doing here is following a pattern. Okay, and I know that pattern is not particularly easy to see. Again, there were a couple of rather difficult things we had left when the school year sort of abruptly went to e-learning. So if you have questions, you got to make sure you bring those up. Okay, don't just phone it in, because we still got to get this assignment right in order to get your Algebra 2 credits. Okay, got a couple more examples down below. Anybody have any questions before we advance? If not, grab your screenshot, get ready to go. All right, so here's a couple more here. We'll do these two, and then we'll move down and try that last one. And again, remember, we've got our rule. A cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. Okay, that is our pattern that we are following. So here we have a difference of two perfect cubes. Okay, we've got eight p cubed is 2p cubed. 216c cubed is 6c quantity cubed. Okay, you got to be able to recognize that in order to follow our pattern. Okay, A is 2p, B is 6c. So when we factor this, it becomes A minus B which would be 2p minus 6c times a squared, which would be 2p times 2p, or 4p squared, plus a times b, which would be 12p times c, because it's 2p times 6c, plus 6c squared, 6c times 6c, which would be 36c squared. Now, the good news is that when we do sum and difference of two perfect cubes, the trinomial never factors again. It is always prime. So when you factor this, you don't even need to look at the trinomial. It's done. Now, the binomial, on the other hand, it could factor again. So you have to watch those binomials. You have to check and make sure that you're actually finished. Now, in this case, we have actually a GCF that we missed that could be pulled out of these, okay? So when it says factor completely, we have to make sure we've pulled that GCF out of there, okay? So if you'll notice, you can take a 2 out of this first set of parentheses, and you can take a 4 out of the second set of parentheses. So we'd be looking at 2 times p minus c, and over here we'd be looking at 4 times p squared plus 3pc plus 9c squared.
which gives us a final answer of 8 p minus c p squared plus 3pc plus 9c squared. And if I would have caught that GCF at the beginning of the problem, it might have been an easier thing to deal with, okay? That's why it's so very important to always check for the GCF first, not because you can't take it out later, because you can always take the GCF out. But because if you don't take it out at the beginning, then there'll be GCFs all over the place that you have to take out and deal with along the way, okay? So remember, always check for that GCF. Don't do what your teacher just did and completely ignore it until you're done factoring the problem and then have to go back and take it out at the end. Okay, always check for a GCF first. That's right, I am admitting to a mistake. Okay, how did I get the 8? I got the 8 because I multiplied 2 and 4 together to get 8. Okay, is everybody good on that one? Okay, so one more relatively easier one, and then we'll look at that last one, which gets a little crazy. Okay, but that's all right, we'll survive it. So the next one here, there is no GCF, but this does fit our pattern. Okay, and we've got x squared cubed, that would be x to the 6th, minus y squared cubed. So that fits our pattern of a squared minus, or a cubed minus b cubed. So that will follow the same pattern that we've been doing with the others, okay? That fits our pattern. So now we need to break it up into our two things. Our binomial, which is a, which is x squared, minus b, which is y squared. And then our trinomial is a squared, which would be x squared times x squared, which would be x to the 4th, plus a times b, which would be x squared, y squared, plus b squared, which would be y squared times y squared, or y to the 4th. Now, the trinomial is done. As I've said, it can't be factored again. At worst, if you missed a GCF, you'll be able to take a GCF out of there, but there's no GCF in that trinomial either. So the trinomial is done being factored. But this factors again because that is the difference of two perfect squares. Okay? So that would factor one more time into two binomials, x plus y and x minus y. And then we would still have the trinomial on the end. Okay? So that first two set of parentheses, these are coming from here. Okay? So that would factor again into an x plus y and an x minus y. Any questions on that example before we continue? Remember, these do say factor completely. So if you fail to factor something, any part of it, if you miss a GCF, if you don't notice a difference of two perfect squares at the end, that would keep you from getting it right on Delta Math. So you need to make sure that you factored it completely, all the way out. Okay? Got one more example to do. Grab a screenshot if you want one here before we move forward. Okay. So this last one is going to present some unique opportunities for adjustment. like I said that way. First off, it is a sum of two perfect cubes problem. So remember that that's from the first rule we learned today. It will factor into a plus b times a squared minus ab plus b squared. Now when we're looking at this, that is y to the third cubed and 8 cubed. Okay? So we factor it into a plus b, that would be y cubed plus 8. And then y cubed times y cubed would be y to the sixth, minus y cubed times 8 would be 8y cubed, plus 8 times 8 would be 64. Okay, again, what we're doing here is we're following that same pattern. Okay. Now, here's the fun part. The yellow portion of our factored form is still a sum of two perfect cubes. So it has to be factored again. Okay, this part is done. This part has to be factored again, because it is still a sum of two perfect cubes. That part there is y cubed plus 2 cubed. So this blue part we're just going to leave sitting on the end. It's done. We're not going to touch it. Okay? But this part is now the green. It's now the green portion. It factors again. So it will factor into y plus 2 times y squared minus 2y plus 4. And then we will still have the blue trinomial sitting on the end. And that would be our final answer right there. That whole ugly mess of a factored out trinomial, or factored out polynomial. Okay? We would factor all the way out into y plus 2 times y squared minus 2y plus 4 times y to the sixth minus 8y to the third plus 64. Now, the good news is that your assignment is not going to include problems as complicated as these last two for the most part. It will be relatively rare that when you use the pattern the first time that it does factor again. Usually it'll just be the one time. Now, there are going to be a few problems like these ones up here that had a GCF that we have to pull that GCF out first. The blue one in the middle there would be the one I'm talking about. So you need to be prepared for that possibility. You need to make sure you take the GCF out before you follow your factoring pattern for sum or difference of two perfect cubes. Okay? So real quickly, the last thing I want to say here is remember that you've got your two different rules. One for the sum of two perfect cubes and one for the difference of two perfect cubes. And I want you to notice how close those two rules are to being exactly the same. Okay, here's your two rules right here. So you need to write those down somewhere, because when you get into Delta Math, you're going to need those rules, the things I just boxed. These are your rules right here. You need to know these. You need to have them handy so that you can refer to them. Okay? Your Delta Math assignment today, I think I asked you to get 7 or 8 of these factoring problems correct. It should be posted. It should have posted 5 minutes ago to Delta Math. So again, we're on deltamath.com is where your assignment is located, and it is due tomorrow at 3:30 p.m. Any questions?